Welcome to this video session. I am Dr. M. Saravanamuthu, Assistant Professor, Department of Computer Applications, Madanapalle Institute of Technology and Science, Madanapalle. Today, we are going to see various types of pointers in C language. This is most important topic we know, the particular language called C. Let us start the session. So this is the agenda of today's topic. What is mean by a pointer in C language, how it is referred as a user-defined data type, and what are the special notations we are going to use to apply pointers in our coding that we will see. Then there are certain rules we have to follow when we are applying pointers. So there are some pointer rules also. Then come to the actual the types of pointers what we are going to see probably in the second session. Let us start the session. So what is a pointer in C language? So pointer is a programming language object in theoretical way whose value refers to points to another value stored elsewhere in the memory using its memory address. A pointer references a location memory, and obtaining the value stored at that location is known as a dereferencing pointer. We know RAM is a storage part for our working execution of coding and everything. So in that, the pointer is taking one address of the particular memory location. That is the meaning. So whatever the value we store in that, it will be there in the pointer. So it will, through programming we can able to access the pointer, the corresponding value also. Let us move to next slide. So in another way, we can say pointer is a user-defined data type, which can able to create special models, so which creates special types of variables, which can hold the address of not necessarily a single variable. Normally, what we do with the primitive data types like a character, integer, float, and double, and also we can able to apply user-defined data types. So we can able to create a pointer for a function. That is also pointer called function pointer. This is a special case in the pointer level in programming C language. Followed by the derived data type, what we have array, structure, union, enumeration. For this also we can able to apply pointers. So we can call the pointer is one kind of user-defined data type, like array, like other things. Let us move on to the next slide. So this is example. So first example, we are declaring a pointer name called PTR, the data type integer. So it is going to point integer data value. So the integer pointer pointing to integer data value. Next, we are defining a pointer function. So I'm using special notation here. So the pointer notation is enclosed in a bracket, and the function is as usual we are representing in the parentheses. So this is called a function pointer to a particular function that we will declare by later. The last one is the pointer to an array containing set of elements. So here there are say, 5 array references given. So the pointer name PTR is going to point 5 memory locations. So this is also possible. This is a special case with the pointers. Normally, we create a pointer for primitive data types. Now, the facility is available in the language. We can extend to functions as well as arrays and derived data types also. And the notations, what already we have seen in the example, here we are using some operators called the pointer notations, particularly the ampersand symbol, and symbol called unary or monadic operator, called it is referring the address of variable. So whenever the pointer variable attached with this, prefixed with this symbol, ampersand symbol, this is referring the address of the particular memory location. This is one notation we have to follow. Second thing, what content we have in that address, just like a door number and home. So the address operator is giving the door number. We reach the place, address, and the next, the indirection or a dereference operator star asterisk will give you the content of the particular memory location. What value we are having in that location. So it all depends on the type of data also. Suppose if you are creating integer pointer, integer data will be available. If we create a float pointer, float data will be available like that. So the notations that we have to familiarize. Address a variable using the ampersand symbol, star notation, that is asterisk notation. It is referring the content of an object. That is a declaration model in the last line. So data type, so what we are referring here. mm, So data type, what type of data we are going to create pointer, then the variable referring the pointer name, then prefixed with the star symbol, asterisk symbol. So this is the not a creation way to create the pointer. These are some examples and valid pointer declarations what we follow with say integer data pointer. So IP I am creating as a pointer with a star symbol. So this is pointing to an integer. So this integer pointer can hold only integer data. That is a restriction with the pointer. Particular data type only we can able to store in that address. Second thing, double data type, so star DP is a double pointer. It is going to point a double value. So the numeric float value, double value we can able to store here with more accuracy also. So third one, float FP star. So this can store a float pointer, float value. That's the meaning of these different primitive data type models also. So the char pointer CP pointing to one character. So all these are handling the primitive data types only. Integer, double, float, char. So each pointer can able to store corresponding data values. That is the important thing in pointer. Pointer, because pointer can point to any memory location. What value we are going to store, that is important. So the declarations, the type declarations itself shows I am going to store integer data. I'm going to store double data. I'm going to store float data, like we have to mention clearly. This is the next example, how the notations we are going to access. So here, I'm creating the integer pointer IP as a pointer type. So star indicates. Next, I'm creating an ordinary variable A with the value called 10. So there are two variables. One is ordinary variable A and one pointer integer variable. So now I can able to get the address of the ordinary variable stored into the pointed variable IP. The type should match. So integer pointer can able to point only integer. So I have the very ordinary variable A. Now I am next to the line. I am getting the address of the variable A to store into the integer pointer. So IP equal to the address of, that is ampersand symbol and symbol A. So now this is going to return, this is going to give the address of A where it is the value 10 is stored in the memory. Now IP is going, IP we can say clearly now pointing to A. The integer pointer is pointing to A. Next we are printing the values. So IP, I am just printing the normal way notation. This will print the actually the value what IP is having in memory. So the percentage U, it is unsigned value. So because memory there is no signed value, it will start from 0 to maximum value. So the U referring unsigned value. Even we can use D also. Sometimes it will show the negative values also. So this line, first printf will be displaying the address of the particular integer pointer. Next line, I am going to access the content of the particular address. So star IP, so I know the data type is integer, so I am using %d for decimal. So I can use it for I also. So star IP will give you the content of the particular address where the 10 is available. Because 10 is available in particular memory location called A, where A is stored. Now we are pointing to A. So A will be showing the content. So that's why the reason we are calling the star symbol as an indirection operator. It will access the value through the next another variable also. And next, coming to the rules, what we should follow for accessing, for using or utilizing pointer concepts in our programming. There are some simple rules which will help us to get the memory access easily. So the rule 1, I can do addition or subtraction or increment or decrement, pre-increment, post-increment, pre-decrement, post-decrement to get the next address and previous address also. This is valid, allowed. So here example, here say address plus number. Say any number you can give. So equal to address of next. It will give an address value, an integer value. This is referring the next address. The same way I can go for the previous address by giving the subtraction operation. Address minus number. It will go to previous address. The same thing I can apply by using increment decrement operators in both the ways, prefixing and postfixing. So the address plus plus is going to access or show the next address. Address minus minus will go to previous, like a plus plus address will go to next. So this is rule 1, will allow us to access the previous and next addresses easily. Because as a pointer, we have only one address which is pointing to some memory location. From that location, you can able to move next address, you can able to move previous address also. So throughout the memory, entire memory, we can process through these plus plus minus minus operations. This is one flexibility to the pointer so that you can access the entire memory. Rule 2, we can get the size of particular memory location also. So there are 2 addresses we have, means we can subtract the address by using this, we'll get a number. And also the number will is divided by the size of the particular data type, we'll get the number of elements in the pointer. So how many elements we have? See the example given here. Integer, we have a comma b, 2 variables, ordinary variables. And there are 2 pointers, P1 and P2. Now I'm assigning the address of A and B to the corresponding pointers P1 and P2. So P1 is holding the address of A, P2 is holding the address of B. So now P1 minus P2 divided by the size of integer, because size of the data type, will give you the total number of memory locations available here. So because once we have access to memory, we should know how many locations we are accessing. That is possible here. So rule 2 allows us to do this. Rule 3, there are some other operations which are not allowed to do in pointer related operations. Say here, adding 2 addresses, multiplying 2 addresses, subtracting 2 addresses, dividing addresses, applying modulus operator. These are all not allowed in. You can't do except a subtraction process. We can do subtraction. Previous rule says subtraction allows to give the number of elements. Except subtraction, you can't do 2 addresses accessing at a time by using other arithmetic operators, addition, multiplication, division, and modulus or remainder operator. So this is rule 3. Rule 4, we can use relational operators to get the address value less than, greater than, or equal, like that. So it will return true value, true, false value, Boolean value. So address greater than address, it will give true or false. So address less than or equal to. So these operations are available. Rule 4 allows us to apply relational operators in pointers also. This is also another facility. Suppose whether we are in the first address or in the last address, this is known by using the relational operators. Suppose we are going for a pointer array, where we are in, which first array location or last array location. So this we can confirm with the relational operator. Under rule 5, we can't apply bitwise operations on pointers. So all bitwise operators, single ampersand and vertical symbol for OR operation, XOR operation, then complement operation, all these are not available, not allowed in pointers. And finally, rule 6, we can find size of a pointer using size of operator. That already we have seen in the rule 3, right? By subtracting two addresses, we'll give a number of locations so that we can identify how many elements are there in the memory in our process. So these are the rules we should follow while applying the pointers. So by by keeping these rules in our pointer access, this will help us a lot to simplify the code also. And the actual topic where we are moving for here now, the various types of pointers in C. Excuse me. So these are the different types we have. Normally, we say only pointer in C, but in pointer itself, we have this much of variations. So there is a called a null pointer, a dangling pointer, generic pointer, wild pointer, near pointer, fair or huge pointer, complex pointers, function pointers, array pointers, multi-level pointers. So all these are the various types of pointers. So this we will be focusing in the next session. So the details of this entire types of pointers we will see in the next session. If you have any queries, kindly send your feedbacks to this feedback link. Thanks for watching the video.